I think we're almost set to start the second session, which is going to be about architecture and patterns and like the way you design your app, the way you think your app. And as you probably know, for all conferences, there's kind of a code of conduct. And part of this code of conduct is saying that you have to have a talk about functional programming, reactive programming, or something like that. And this is the moment. So that's where we are going to talk about monads, functors, applicators, observables, and things like that. No, just kidding. We have here Florent Pillet, who's going to talk to us about reactive programming, and especially RxSwift. You might probably know Florent because he's really involved in the French community, Coco community for a long time. And he's also the author of NSLogger, which is a great, if you don't know if it's a great alternative to NSLog console. So you need really to check this out. And that's it. You're going to dig into that right now. Thanks. Thank you.
Thank you. Hi, everyone. My name is Florent, and I'd like to introduce you to the world of reactive programming and RxSwift. Before we begin, let me introduce myself. I've been working for a long time on many platforms and languages, and I've been doing development since the iOS native SDK has been released. I'm a freelancer, and I also do open source development on my spare time. I first discovered reactive programming 3 years ago with Reactive Coco and Objective-C. It was difficult to learn at the time because it was not very well documented, and sources of information were scattered all over the net. I kept learning, and after a while things clicked. It takes time to click. Learning Rx was really difficult, but I'm glad that I went through the process because it changed the way I think about code. So I'm very excited to talk about this today. And I hope I'll get you some of the excitement as well. So here is the agenda for today. I'll briefly introduce Rx, and I will show you how observable sequences are created, because this is one of the mysteries that people don't understand at first when they start doing reactive programming. This talk is about programming patterns, or the way we do things and solve things in Rx. So we're going to see some basic programming patterns, some user interface patterns, and I'll end up with architecture patterns briefly. There is a lot of information in this talk, so feel free to get the slides when they are available and use them as a starting point to dig into Rx, because I won't have the time to cover everything today. So first, a bit of history on Rx. It got popular when Microsoft released the .NET Reactive extensions in 2009. Since then, many implementations surfaced on several platforms in several languages, and they all share more or less a common API, which is grouped under a website called reactivex.io, which is the main source of information nowadays on Rx. RxSwift appeared in 2015, so it was last year. It got mature very, very quickly. And the guy who wrote it initially pulled all the ideas from the Microsoft framework and source code, and he went as far as replicate the whole test bed. And the quality of the framework was immediately very high. So this is the one I picked when I moved to Swift, and I'm very glad I did. Reactive programming has been here for a long time. Much more than you think, actually, because this is VisiCalc. VisiCalc was the first spreadsheet which appeared in 1979 on the Apple II. Spreadsheets are a very good example of reactive programming, because when you modify a cell in a spreadsheet, all the cells that depend on it recalculate their own value, and everything updates automatically. Changes cascade, and you don't have anything to do. This is what makes spreadsheets so valuable, because they are reliable, and you can count on everything working. So let's dive a bit into the basic ideas in Rx. If there is only one thing you remember from this talk, it's that Rx is all about observable sequences. Every bit of data you have, every event, every result of calculation, every network request, every state change in your application can be modeled as an asynchronous observable sequence. Sequences can deliver 0, 1, or any number of elements. Some of them complete, some of them end up with an error. But the real power of Rx comes when you start composing and transforming the sequences. You create new sequences by applying operators, like the filter operator I showed here. It's tiny, sorry. Applying the filter operator to an existing sequence will create a new sequence which you can subscribe to. We are going to see a few operators in this presentation. There are many, many more that are available on the website. So, oops. Okay, so let's have a look at a simple example to see what reactive programming looks like. This is a small bit of code which performs a request. It's going to fetch the weather in Paris from a publicly available API. As you can see, the process can be read from top to bottom. We start here, and you read it this way. It's very close to what we do in Swift with maps on arrays and stuff. So let's go through it. First, we create a new observable sequence using an extension method of NSRealization, which is called RxJSON. And RxJSON will perform a request, will fetch the result from the API, decode the JSON value, and send it as a single element as a dictionary. Next, we map, we convert this JSON result into the object we really want, because we just want the temperature that the API returns. So I just tried to pack the JSON decoding here. And I'm creating a new observable sequence with map. So I went from JSON to float. It's really two different sequences. Finally, I will subscribe to the sequence which returns a float, and I can display it. And I'm done. I really expressed in 3 lines or 4 lines of comments what I can do in Rx. So what did we just see? We saw a sequence which emitted one item, then completed. This is the JSON sequence. We saw a map operator which transformed the item emitted by the first sequence into a second sequence which emitted a float. And finally, we subscribed to this and we displayed the temperature. So it's very similar to what you do in Swift. It's just asynchronous, because even though you can read the code from top to bottom, everything occurs asynchronously as the network request comes back. So we can represent what happened as a diagram. We call them marble diagrams because we represent data as marbles on a timeline. Because everything being asynchronous, we have to show time as well. Marble diagrams are very useful to understand what's going on in Rx. And they are the basic way of explaining the operators you'll find on reactivex.io. And there is a very nice website which is called rxmarbles.com. I highly recommend that you go and see there, because the marbles are interactive. So you can play with the sequences and you can move the data and you can see what happens when data comes back later or earlier. So let's talk about the observable sequence lifecycle. An observable can emit 0, 1, or any number of elements. All elements are of the same type. It's exactly the same as the basic Swift stuff. This is called the next event. There are 2 types of sequences. There are finite sequences, like I showed here, and there are infinite sequences. The network request is a good example of a finite sequence. At some point, it will come back and either return a result or an error. An infinite sequence can be, for example, a subscription to a notification, which will never end unless you stop listening. The subscribe method we show here has a number of optional parameters. We are only using 2 of them right now. It's next, on next to get the next value, and on completed to get notified when the sequence completes. We can also listen for errors. obviously some type of sequences like the network request are able to send errors. So we want to know when the sequence errors, because after an error occurs, nothing is emitted anymore on the sequence. And you can also optionally subscribe to the disposed event, which happens when the sequence has completed or when someone has canceled the subscription. In this case, you get a disposed event. A subscription always returns an object which is called a disposable here. It's very important because this is the object you can use to cancel the subscription to the sequence. So when you want to stop listening or stop the subscription, you just call the dispose method of the disposable and you're done. Now, let's talk about one of the things that's the most confusing for newcomers. How do you create observables? How do you feed them with data? There are several ways to do this with RxSwift. It has a rich API for you. Let's start with RxCoco. RxCoco is a module which is part of RxSwift and is specifically tailored to user interface stuff. It provides the extensions to UIKit on iOS and to AppKit on macOS. For example, you can easily subscribe to any kind of notification using the Rx notification extension, which returns an observable sequence for the notification you want. And you will get called, your subscription you will get called every time the notification fires. And you can use the disposable here to stop listening to your notification. So it's very straightforward. You don't have delegates and stuff. In this other example, we use the Rx text extension of UI text field. The Rx text extension emits a string every time the user types a character. So every time something happens, you get successive values of the text field here, and you can process them. In this very simple example, I just print the result, but we could combine them, something we'll see later. And one thing is I ignore the disposable object that the subscription returns, which means that I'm subscribing to this text field during the viewDid load here, and I will never unsubscribe. So the subscription will run until the text field is deallocated. Now, you can also create sequences manually. It's a bit more complicated than just simply using an extension, but it's not a big deal. What you do is you create an observable using the create method, which takes a closure, and this closure gets called every time someone subscribes to your observable. In this example, I will just send two strings, 1 and 2 here, and then I complete, which means that the sequence ends. So the subscription ends for this subscriber. And you can also return an object which is disposable. This disposable object is called when the subscription is cancelled or when your observable completes. Here I don't have any cleanup to do, so I just return a not disposable. Here is a more complex example which performs an asynchronous computation. When you subscribe to this observable, it starts computing things asynchronously. When the task is done and successful, we return the result, then we complete. When there is an error, we just emit an error. Since this is an asynchronous task, if the subscriber wants to cancel his subscription, he will use the dispose method. When the dispose method is called, our disposable is called itself, and we can cancel the task. This is also called when our sequence ends. So you have to take provisions if your task doesn't support being cancelled after it's done. If you want to, one of the things you have to realize that every time someone subscribes to this observable, the task starts again. So if you just want to share one run of the task with every subscriber, RxSwift has operators for that to share subscriptions and replay what has been done. There are more ways to obtain observables. I'm not going to cover them all here. You can turn any array or collection into an observable sequence, which emits all the events one after the other nearly at the same time. There is the delegate proxy class, which is a very, very useful class because it lets you intercept the delegate pattern of iOS and macOS and create delegates for UI collection view, UI table view. This is the way. There are lots of classes in RxCoco which do that already. RxObserve is a way to turn KVO into observable sequences. RxSendMessage turns selectors by swizzling into observable sequences. Obviously, you cannot observe selectors which have to return a value because you can't return a value. And finally, subject and variable are two very interesting observables because they are observables you can feed values to. So you send them a new value and all the subscribers to the observable will receive the new value. So it's a very good way to get started with Rx with minimal cost. Even though it's not the way we recommend you work, it's still very nice. Now, let's see how Rx can help you solve programming problems. We are going to take some basic tasks and implement the solution with RxSwift. Our first task is going to be, oops, sorry, yeah, it's a bit slow. So the first task we have to do is to have a screen with a text field, and when the user enters a city name in this text field and presses a button, we are going to fire up a network request and get the temperature in the city that's been named. So to do that, we are going to connect a button, a text field, a network request, and feed the result to a label. We are going to use a composition. Composition is a fantastic way in Rx to mix different kind of things. We are going to first intercept the taps on the button with the Rx tap extensions. So this is the first sequence of taps. Every time there is a tap, there is an event on the sequence. We are going to compose the taps with the with letters from operator, which is watching the text field's text. And it just remembers the last value that's been received on the text field. And every time the button taps, it will emit the latest version of the text field. So if we start typing Paris in 3 times, when we tap, the with letters from will emit Paris. Next, we are going to flat map. If you played with flat map in Swift, you know that it flattens arrays. Flat map in RxSwift flattens observables the same way. So what we do is we get the text from the text field in a closure, and we're going to return a new observable sequence, which is our network request. Flat map subscribes to it and flattens every value sent by the sequence on its own output sequence. So in this case, it will output a float, because the get temperature method I don't show here takes the JSON and outputs a tuple with the city name and temperature. And finally, we subscribe to this, to the output of flat map. We subscribe to it, and we can format the temperature and say in the label, now it's 20 degrees in Paris. So again, you will be able to reread the slides and the code, but it's easier to read once you start getting into Rx. It's very, very simple. Our next pattern is aggregation. We want to get the temperature in multiple cities at once. We want to get temperature in Berlin, London, Madrid, and Paris, and Rome. So to do that, we are going to have to fire 5 network requests. It's very simple to do with Rx. We take each of the city names in an array. We turn this array into an array of observables. For this time, they still don't do anything. They just sit there. So we convert them to a single observable, which is an observable of all the sequences. We merge them to a single sequence, which will output the result of each individual sequence. One sequence. Sorry. Hello. So we merge our result, and finally we use the toArray method here. toArray is an operator which takes all the values from a sequence, waits for it to complete, and outputs one item with an array with the sequence of everything that's been output. we subscribe to this result, and we get at once the result of all our network requests. So it's incredibly easy to make that kind of things with Rx. If you want to start with Rx, start with network requests. It's a great way to get a feel of what you can do. Our next pattern is cancellation. Most of the time you want to be able to cancel the subscriptions to observables. Let's take an example. We want the temperature in Paris to be queried and updated every minute. Only while the view controller is on screen. As soon as it goes on screen, we just want to cancel the subscription. So to do that, we create an observable timer. Observable timers are fantastic in RxSwift because they are a so simple way of doing cancellation cancelable timers. We take our observable timer. Every time it fires, it's going to emit an integer. We just discard it. We don't need it. It's a counter. It's going to fire every minute, and every time it fires, we create a new observable sequence, which is a new query for the temperature. We flat map this result, and we used a method called bind_to. Bind_to is like a subscribe, except that it will feed the contents of the sequence into an observer, and the label happens to be an observer with the Rx text method. So it's very straightforward, and it's wired once. It always works the same way. When the view disappears, we are going to dispose our timer, and the subscription cancels. So we're done. It was very easy. Now, you may have noticed that in the previous examples, we have not been handling errors. Let's see how we can improve this. Network requests can fail for many reasons. So if we fail to get the temperature, we want the user to see a couple dashes, just to say, okay, we don't have the latest information, so just dash. For this, we first create a function which is going to turn our temperature into a tuple with a string, so we can replace the string if there is a failure. In this case, the get temperature is an observable. We map it to our tuple, and then we add catch error just return, which is in case this process fails, we are going to catch the error and return a generic tuple with the city name and a couple dashes. And we use it this way. We again intercept, tap on a button, use with letters from to get the city name, flat map to our get temperature string observable, which catches errors, and map it here. We just do a print. So if there is something wrong, it's going to read its dash in Paris, which is not very useful, but we get the idea. And we bind that to the labels text. So this takes us to user interface patterns. I'm just going to see two of them. The first one here is driver. We didn't care about threading at all in previous examples. But network operations, for example, most often run in the background. If you are doing lots of complicated operations, you do them in background queues. So we obviously want to update the UI in the main thread. And so we want to guarantee that everything that's bound to the UI isn't going to fail, because when a subscription fails, you have to resubscribe for it to work again. So RxSwift has provisions for this. The driver unit is a special class. It's a special object that works like a smart observable. It guarantees that every event is going to be delivered on the main thread. In addition, it guarantees that it never fails. So when we create a driver, we use the as driver on any observable, and we pass a default value to indicate what to emit when an error occurs. And this way, if anything goes wrong, you get a template value. Driver has a special syntax. Instead of bind, we are going to use drive. It's just done to make it clear that we are using a driver. We could have bind_to API that it existed before, but it's just more clear. So driver is ideal for driving the UI. I recommend that you explore this when you get more familiar with Rx. The next UI pattern I want to talk about is action. It's not technically part of RxSwift, but it's a very useful tool you can use to bind the UI. Action is a way to trigger actions from the user interface in generic ways. In addition, it can log the UI because if you call action, it's going to be logged until the action is complete. And the way it works is with observables. An action returns an observable. So when you execute the action, you return an observable, and as long as this observable doesn't complete, the action is locked. So here, we still have our button to get the temperature, we still have our text field where we enter the city name, and we still have a label to display the result. We're just going to wire the things a bit differently. Our action, when executed, obtains the latest string from the text field in a non-reactive way. Sorry, for this example I made it short. Then it returns an observable, which is our familiar get temperature string, which is our observable request. And we subscribe, so we set the action on the button first. So when the button is pressed, the action is executed. And then the action has an observable sequence called elements. And elements relays all the events emitted by each individual action as an observable. And we bind this to our text label. So in the end, every time the button gets pressed, a request is made. When a request comes back, it gets turned to a string, blah, 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 and is bound to the label's text. And it all works in a very simple way. You see that in just a few lines, we did something relatively complicated. But action is much more than that. It's really a powerful pattern that you can use, especially when you are doing MVVM, because it really enforces separation between the view and the model. Now, to conclude this roundup, let's review let's talk about architecture patterns. I'm not going to get into details, but more on generalities. The first thing is that when you are developing your application and when you get familiar with Rx, you tend to more and more expose all the data through observable. This has many advantages because when you do this, you really don't care about the updates. A subscriber who subscribes to an observable is going to receive data every time a new version of the data is emitted. You want to use the action pattern to wire up the UI whenever possible. It's very good with MVVM as well because you expose actions in your view model that you use, you connect them, you bind them in your view controller. Going further, you want to decouple your application logic from the infrastructure that supports it. By infrastructure, I mean everything that's not relevant to individual scenes in your app. This can be storage, this can be network requests, an image cache, geolocation, notifications, and so on. Again, a good way to decouple parts of your application is to use observables to obtain data and to abstract these in separate services with protocols. I won't elaborate, but it's really a great way to insulate every part of your application and to make it testable. Because every time you do that, every time you abstract something as an observable, you can mock this observable at test time, and you don't have any change to make in your code, because your code just subscribes to the observable. So it makes replacing all parts of your app a lot easier. If you change your database, you go from core data to realm or the other way around, and you keep the same way of exposing observables, the user code won't see the difference. So, let's summarize. It was a pretty dense talk, and I hope that I didn't lose too many people. Reactive programming is a powerful way to express your program logic. We saw that in a very few steps and in very few lines, you express complicated processes. This is one of the great benefits of using Rx. Reactive programming models the asynchronous propagation of change. By that I mean that it models the processing we do on changes over time. It can also help eliminate state from your code, which is a great way to reduce the number of bugs, because the less tests you have on state, the less problems you have. Your code is more testable because you can separate the observables from the production of data. So you can replace data production at test time. And finally, RxSwift is a very solid foundation. It's very, very great code. There is a lot to learn by reading it. And it's very well written. It's extremely well tested. And there is a fast-growing community of users. We have RxSwift community, which is a pool of projects around RxSwift, which provide a lot of extensions on different subjects, like, for example, RIM, core data, Alamo Fire, and stuff. Here are a few links you'll be able to refer to. There is Artsy has a whole application which is written with RxSwift, and which is a great example of a whole iOS app. The ReactiveX website is a primary source of documentation on operators, and rxmarbles.com is a great way to experiment with operators and with sequences. On this, I'm done. Thank you.
Yeah, thanks for this deep talk.
Yeah, a bit technical, yes.
No, I mean, did you like that, guys? Like the fact it's technical? Yeah, we're here for that, so thanks. So on the community side, like people can be really afraid of like making their whole apps rely on some kind of third party for such an important part of the architecture. So, okay, I get the message. There are people involved and stuff, but how can you be so sure that it's not going to break at some point?
You mean RxSwift?
Yeah.
You can never be sure. You have the source code in case, but it's really extremely well tested. Really.
And what about the source code? Like, is it easy to jump in if you have some problems?
It's easier than it was with Reactive Cocoa. Yeah, Reactive Cocoa was really complicated, and RxSwift is extremely well written. It's well separated. It's totally modeled after Microsoft Reactive extensions. Even the tests, what he did is took all the test bed from Microsoft and just copy-paste all the tests, which means that every operator is tested in a way that we guarantee it always works.
Yeah, we can make fun of Microsoft for a lot of things, but
no,
on that kind of stuff, they're really solid.
So you talked about Reactive Cocoa. I guess you were expecting the question since like 2 years. So how do you think about the comparison between Reactive Cocoa and RxSwift?
I don't want to enter this debate. The debate between, I guess the choice between Reactive Cocoa and RxSwift today is more about, do you have legacy code in Objective-C? Do you still want to use reactive code on Objective-C? In this case, you want to choose Reactive Cocoa. I chose RxSwift because at the time I started, Reactive Cocoa was not stable in Swift. It was crashing a lot, there were threading issues. RxSwift was seemingly much more stable, and I'm very happy with my choice. Now it's a personal choice. One of the great benefits of RxSwift is that the API itself is more or less common with all the other languages, like RxJava, Kotlin, Scala, whatever.
Totally. Yes.
So it's a great benefit when you work in a team, because everyone talks the same language.
Yes.
Yeah, and about language, like it seems when you look at that, when you look at the code, at the slides, you may think, okay, it looks much more complex than usual imperative code. And is it really something that is that has a deep, steep learning curve, or is it just that we're not used to it? And
the learning curve is still steep. I mean, there is.
How long would you spend to learn it properly?
It depends on the person. It took me a couple of months to really get into it. It can be a couple of weeks. It depends on the time you have. I think it's easier now because with Swift, you are trained to think functionally, and you make the jump more easily, I guess.
Yeah. That's a big difference.
Yeah, I have another question. Okay. So let's say you have an app with some synchronous design. would you recommend to have everything done with Rx, or would you mix and match Rx and I know promises?
Promises are a good first step to get into Rx. I think that as Rx is a much more evolved version of promises. So you don't need promises once you use RxSwift, because you have every tool that promises give you is in RxSwift as well.
Yeah,
But is it a good path, like starting by promises?
Yeah, it's a
and
good
things
path.
like that?
Absolutely, yeah. You have to learn to think asynchronously, and you have to learn to think about things in terms of sequences. Once you get to this stage, then it becomes easier. So you can, after promises, you can use RxSwift, you can use Reactive Cocoa, you can use. There are other frameworks as well. There's SwiftBond.
Yes.
There are like 5 or 6 of them.
Yeah, there
Interstellar as well.
Yeah, Rectificate. Yeah, there is a good blog post by Ash Farrow with a button that says choose for me the best reactive framework, and just pick one random, and there are many good ones.
Yeah, that's about the idea. Just a quick poll for the room, the audience. Jean-Mi, if we can have some lights. So who uses some kind of reactive framework? Like, well, it's
congratulations.
Like, I don't know if you can see yourself, but it's probably half of the people here. So that's nice, promising.
Yeah.
Okay.
What's amazing is that if we had asked this question like 6 months ago or 12 months ago, we will have just 4 or 5 hands, and now it's almost half of the room.
It's amazing.
It's amazing, yes.
Yeah, but
it's nice.
Just one thing I want to say is that the first time I wrote a full application at the time with Reactive Cocoa, the one surprise I had is zero crash. Is once you write code in a functional way,
that's a big promise,
with observables, then you eliminate a big part of your problems.
Yeah. I can believe that. Okay, let's continue this conversation after, but for now, time for the next talk.
Thank you.
Yeah.